So we're going to talk about ugly code, which is something you probably don't spend, hopefully you don't spend a lot of time talking about that. So can we do something beyond just correctness, right? Can we talk about beauty of the code? And what's our guidelines on how to make beautiful code? And can we actually evaluate beauty qualitatively? Can we do it quantitatively? And how well will these tools work, these metrics work? And then do we have tools to be able to help that out? So that's our motivating question. So we start off with smells. We talk about smells. So does code smell funny? So that actually has a technical concept associated with it. And there's people who write these books about smelly code. And there's, depending on what you refer to, there's 20 common kind of mistakes code smells that cause code to smell, or 60 depending on what you do about that. We'll give you some examples of that in going ahead. But one idea that we wanted to get across was a way to avoid smelly code, and we use the SOFA acronym. And first of all, is it's short. And we're talking about kind of a method at a time doing it. So keeping the method short makes it less likely to smell. Does it do just one thing versus doing lots of things? Does it have a few arguments to the method or lots of arguments? And finally, is it a consistent level of abstraction? What tends to happen is that smelly code tends to violate a bunch of these things, and these will help make your code more fragrant. It got started like short. What does short mean? Well, in the good old days, terminals were 24 lines by 80 characters, so pretty much short was it fit in one screen. These days, with modern big old displays, you could get hundreds of lines of code. Fitting on one giant display isn't short, but the idea is you can kind of look at it and figure out what it's doing. And there is a tool for this. It's, because it's about smells, right? It's called Reek. Reek does it. It catches bad smells for you. So the single level of abstraction is a little bit of an abstract idea. The idea is that it's not trying to do everything all in one task. So here's a task. I'll throw an all-in-one bit method. You're trying to divide and conquer, but yet kind of keep at that same level of abstraction as you're going on. Typically, often, calling other methods to be able to do that, but that all the methods being called are about the same level of complexity. So it's kind of, the best analogy is like writing a good news story. If you took an English class or to become a reporter, you start off with a good summary, and then each paragraph goes into points in more detail, and there's exactly one topic about each paragraph, as opposed to the rambling style where it jumps back and forth between the lots of ideas. So this single level method is orchestrating everything that's going on. So that's one of the goals to try after, the single level of abstraction. So who cares about lots of arguments? First of all, if there's a lot of arguments, it can be difficult to get test coverage. If really there's many different things you have to cover to be able to test it, then that's going to be difficult. And also, lots of arguments can make it difficult to do mocking and stubbing, so that you can isolate pieces of your design to do testing differently. Real danger sign is a Boolean flag, right? So there's a Boolean flag as one of your arguments. So chances are that what that means is there's really two methods hiding in there, and for some reason you put a single Boolean flag. And what you've taken is just made one really hard to test method out of two things that should be separate methods, and trying to avoid that. And then the other thing you may see is a bunch of arguments traveling in a pack together across a bunch of method calls. If that's happening, you should really extract them and to create a new class so that you aren't following these arguments following themselves along. So let's take a look at a smelly program here. So this is an actual program that Armando found that was in the book, and that was what it was, right? You look at it there, and you kind of stare at this thing, and you see letters like Y and D, and if you're a native English speaker, you think, well, what might that mean? And then you see numbers like 365, and if you're on the Gregorian calendar, 365 is a number. So this has probably got something to do with years or something like that. Now this program actually has a bug in it that's be difficult to figure out. You don't even know what it's doing, so much less what the bugs are. So when we run it through Reek, and so Reek is this thing that's looking for smells, given this qualitative evaluation. What does it say about this program? Well, what it says at the top is that it talks about dryness, right? Don't repeat yourself. It says this y plus 1 is used twice here. So at the end of each of these if and else statements, it's the same statement. So you're doing it twice where you could get away with it once. Next thing it says is the method is long. So length is kind of in the eye of the beholder. Now the Ruby code's really powerful, so even a bunch of statements like that is pretty long. But a lot of it is this nested if statement is kind of hard to figure out. So it's suggesting it's kind of a long method. After that, it starts complaining about these single letter variable names, both as a parameter and then in the while loop and again. So that's what and even for this, whatever this is, 15-line little method here, there's a bunch of things that Reek says it smells funny. And again, if you weren't an English speaker or if you're using the Hebrew calendar or something, these numbers, you wouldn't kind of guess what these things mean. So that's the qualitative judgment, and there's a tool to do that. How about quantitative? Well, what people tried to do in trying to create software engineering is, isn't there some things we could try and measure complexity just by looking at the source program itself and adding some things up? One of the oldest one of these things is called ABC complexity, which is a function of the assignments, branches, and conditions. And the formula from looking at lots of programs, looking at lots of procedures, and trying to figure out what's complicated is somebody came up with the formula. Well, we'll square the number of assignments and square the number of branches, square the number of conditions, and take the square root of that. And that's going to be a quantitative measure of complexity. And believe it or not, the National Institute of Standards, which seems like it has plenty of other things to work on, has come up with a cutoff for government contracts about what you have to do to make your method. It has to be not too complicated. So the square root of all that has to be less than 20 for a method for it to be government approved. And Rails, of course, because it's easy. What's fun about the Rails environment, because it's easy to build software, and you're building software for programmers. Programmers make tools for programmers. So there's a program called Flog that will automatically calculate your ABC complexity for Ruby methods. But the most well-known quantitative measure, it's called cyclomatic complexity. And the idea is to try and figure out how many independent paths are there through a method, because that will tell you something about what you have to do for test coverage. You have to cover all those methods. And so again, and this guy, his name's Charles McCabe. He did this almost 40 years ago. He invented this complexity, and his formula was, well, let's talk about these nodes, but nodes are basic blocks, right? One branch in, one branch out. There's no branches inside them. So let's count how many nodes. That's n. The edges are between the node. That's the edges there. And then connected components are these things that kind of are connected near each other. So the Charles McCabe complexity or cyclomatic complexity for this little outline of a one would be 9 edges, 8 nodes, and 1 connected component. So when you pull it like that, you get a connected component of 3. And then once again, the National Institute of Standards has stepped in, defined what government contracts has to do, and it's supposed to be less than 10 per module. And again, in the Rails community, there's a tool, Cycuro, which calculates cyclomatic complexity for you. And so let's go, we'll take a look at that first method we did to go back. So let's just say basically about the quantitative metrics. It's not like these are foolproof methods. Like, oh, if you get a bad score, it's a bad method. These are indicators that something's going on. So if you try a bunch of these methods, and Reek and Flog and Cycuro all suggest the numbers are too big or give you lots of warnings, you probably should take a look at that and see what you can do about it. There's other tools that, well, we talked about simple coverage and testing. Are all the statements executed? That's C0 coverage, Armando talked about a while ago. And simple cov is a tool that'll do that for you in your projects and your tools. And you want to get above 90% in simple coverage. And there's Rake Stats will actually talk about the ratio of code to testing, right? So a big part of test-driven development and behavior-driven design, as we'll talk about today, is having a lot of testing that you're doing on it. It says what the ratio should be twice as much testing code as kind of executing code. So let's take a look at that program, which actually is trying to do some leap year calculation. And so the ABC complexity, the assignments, branches, and conditions, does get a score of 23, which is above the National Institute of Testing standard, so that suggests it's a problem. The code complexity score is under 10. It's not a very complicated, it's a couple of conditions, if statements there, so it's not a lot of parallel paths, and the number indicates it's not a problem. How could we fix that up? Well, let's go through, and first of all, we're pretty sure D was day and Y was year, and we can put that in here, and let's do that leap year calculation. We've got the leap year method with the question mark, so it's returning a Boolean value, and we stick that over there. It's to be able to figure that out, so we've broken that out into a separate private method. So when we put that through Reek, instead of the 6 warnings, one of the warnings was it was too long, and uncommunicated variable names. I can't remember what the other one was, but all the warnings go away. The ABC complexity now, instead of above 20, each method is down around 10, and the Sakura store is below that. So, and this is, intuitively easier code to figure out what's going on. It's nice when you're saying if it's a leap year, that gives you an intuition what's happening here. Okay, so that's, a little bit, you should be thinking about doing this with Ruby. The next assignment that we will give will include these tools. We're not going to grade you on it, but we're going to let you see what the output of the tool. But when the time to do the project that's in this class, we'll be running these tools over your code so to help you improve the quality of what you write.